Okay, look, we're graphing the sine function, right? So obviously, the only column that we care about here is the sine column because it's the sine function. I know that's really like duh, but no, really, like, I'll have kids look, because you guys want to do sine, cosine, tangent. So we're only graphing the sine function. So the only column that matters is the sine column. Okay, because we have to graph with decimals. You guys are very aware 0 is 0. You know 1/2 is 0.5. So I know this is 1. I know this is 0. Whoops. 0.5. I know that's 0. Negative 0.5. Negative 1. Negative 0.5. But do you know what rad 2 over 2 is as a decimal? That's my phone. Okay. Rad 2 over 2 is the equivalent 0.71. Okay, so 0.71, 0.71, negative 0.71, negative 0.71. Okay, what's rad 3 over 2? It is 0.87. Okay, so we're going to use these decimals to plot here. Fair? Easy, right? That's it, you guys. Okay, so how do I do that? Let's see if we can show everything. I guess we'll pan out. I guess that's good enough. Okay, I'm just short of it. All right, here we go. We want the sine function. All right, so look, at 0 radians, because I'm on radians, this is 0 radians. At 0 radians, sine is 0. So I'm at my origin, 0, 0. Okay? Next, you see a pi over 2. I find pi over 2 here, that's 90 degrees. That's a 1, right? So at pi over 2, I'm at 1. Okay, what would be here then? If that's 90 degrees, what's half of 90 degrees? 45 degrees. What's 45 degrees? Pi over 4. So this would really be pi over 4. And what is pi over 4 at? 0.71. So at 0.71, we are at 75. I'll put 1 here. Okay, we have pi. Pi is 180, so 180 is at 0. But again, what's half of that? It would be at the 3 pi over 4, which is 135 degrees, which is 0.71 as well. Okay, and by the way, it's a curvature. So if you say you're trying to graph this and connect the dots, you're actually curving it. It's doing this. And then it's going to be a concave down parabola, and then it'll be a concave parabola. And that's how you kind of get your roller coaster. Yeah. Yeah. Okay, so now I'm at 3 pi over 2, which is at 270, which gives me negative 1. So now it drops. Okay, 3 pi over 2 between that and pi. Can you see it? No. It's 5 pi over 4, which is negative 0.71. So 5 pi over 4, and it's negative, which is like right here. And so at 2 pi, oh, 360 isn't here. Let's write 360, which would be 2 pi, which is right back to this, 0. It would be at 0. And so halfway between 7 pi over 4 is negative 0.71. And so this is your sine function. Okay, what does the amplitude do? Your amplitude is your max and min. So because your amplitude is 1, you're only allowed to go 1 off of the origin. So you guys see wherever it is at 0, so at 0 degrees or 0 radians, I'm at 0. So if this amplitude is 1, I can only go positive 1 to negative 1, high, low, 1 unit away. If, say, my amplitude was 2, I would go up to positive 2, down to negative 2. If your amplitude was 4, you would be 4 units max away and 4 units min below. So your amplitude defines your high and your low, your min max, from your starting point. But right now, we're just at the origin 0, 0. When we start shifting, you'll get all of your radians locked in, so you're going to use all those points. But for here, that's all it is. Okay, for your degree 1, you guys can basically just repeat this, but do you understand that, right, 0 is the same as 0 degrees, pi over 4 is the same as 45, pi over 2 is the same as 90 degrees, pi is the same as 180, and you can graph both radians and pi. When you guys quiz or test, you're going to have a radians quiz and you're going to have a degrees quiz. You have them both for trig functions. You have to be able to do both. But as long as you have your chart, it doesn't matter. You just have to be able to convert. Obviously, it keeps going around. As you do more and more revolutions, then it's going again, and it's going to keep, it'll keep going up and down. Okay, let me